Hello, grade 9s. Today we're going to be talking about the organization of the periodic table. Okay, so right across the top of your page there, you should have these words, so just follow along. And as per usual, anything in red, like down here, you need to copy down into your notes. Okay, many attempts have been made to create a classification system of the elements, so this has been going on for a long time, and we see these different types. So we have Dobereiner in 1817, then Newlands and Meyer, Mendeleev in 1969, and then Moseley in 1901. And Moseley is the current one that we use. We're going to take a look at Mendeleev and then at Moseley, okay? So first let's look at Mendeleev. So during the time of Mendeleev, there were only 63 known elements, so quite a few less than there are now. You can write down point number 2 here in that big box here. Sorry, I jumped ahead here. No, I didn't. Sorry. So number 2, you're going to write down organized elements by atomic mass and outer electrons. So Mendeleev, in his periodic table, the elements were organized according to atomic mass and outer electrons. Now, right now, you guys have just done an assignment on this. You'll know that they're not organized by atomic mass, but by atomic number. So it's changed. But back then, Mendeleev organized it by mass. And what he did was, the third point here, he left spaces for elements that were not yet discovered. So he was anticipating the discovery of other elements, which I kind of think is cool, actually. Okay, so this was his periodic table here. So as you can see, he left all these spaces here because he knew there were other elements that had yet to be discovered. So of course, this periodic table doesn't look nearly as nice as the one we use now. The other one, it's quite pleasing to look at. Moseley, here's his periodic table here. So Moseley created the modern periodic table. And so number 2 point here is arranged by atomic number and outer electrons, or as we like to call it, valence electrons. Number 3, each succeeding element has one more proton than the element before it. And you'll know that on your periodic table, the atomic numbers are always increasing by 1. So you know that each element, as you move forward, has one more proton in the nucleus. Now, just some terminology here. So we've got periods first. So the periods are the horizontal rows on the periodic table. And so they number from 1 to 7. So these are the numbers here. So we're going to 1, 2, 3, 4, 5, 6, 7. And so they move this way across the periodic table. So number 1 is the first row. So we've got hydrogen and helium in the first period. In the second period, we've got lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, right? So we can go through the different periods here. So I could ask you, for example, which element is in period 3 and is an alkali metal? And then you'd be able to tell me that it's going to be that one, right? And we will talk about the families actually in a minute. I just realized I haven't taught you that yet. Yeah, hold on. Okay. Now, each period represents an energy level or the number of electron shells orbitals. So those words mean the same thing, so you can refer to them both like that. And this, Okay, now groups or families. Now I preemptively told you about this, unfortunately, but the families or the groups are the vertical columns on the periodic table. So remember, anything in red, that's what you write down on your notes there. So groups contain elements with similar physical and chemical properties, and basically everything in one family or in one column are going to have the same number of valence electrons, and groups are also referred to as families. So, for example, this is a family. This is a family or a group. And actually, we're going to go over here. These are the other families, which we're going to talk about here. So these are our columns. They're groups, also known as families. Now, periodic law. So when elements are arranged according to atomic number, resulting in a reoccurring pattern of similar properties in different elements. So that's what periodic law is. So it's just showing that because we're organizing them in this really organized way, we get these reoccurring patterns of properties. And so we can use this periodic table to predict behavior of elements because of that. Okay, so we're going to go through each of the families here. So the first family that we're going to look at is the alkali metals. So this is our first column. One thing that I want you to note is that hydrogen is not included in this family. So hydrogen here is not part of the alkali metals. It actually starts one under at lithium. So we've got lithium, sodium, potassium, rubidium, cesium, and francium. These are the group 1 alkali metals. So you can write this stuff down here. They are very reactive. And they actually are going to explode in water, which is pretty crazy. They have one outer electron. So if you draw the Bohr models of all of these elements, all of these atoms, you will get one outer electron or one valence electron for each of them. If we can watch this video. You know what? The Wi-Fi is really not working that well right now. So this video is not working. But if you Google sodium in a pond, you can watch this video, okay? So this video will be there, and you get these sort of big explosions, and this is just throwing some sodium into water, and that's what happens. It's quite incredible. Okay. No, now it's hung up and doesn't want to move. Hold on. There we go. Okay, so group number 2 is the alkaline earth metals. So this group here, oh shoot, can't really, the resolution on that is not good. That's beryllium, magnesium, calcium, etc. Okay, so these are also very reactive. And they've got 2 outer electrons. So all of in the alkali earth metals, they have 2 outer electrons. Hydrogen, this is our group all by itself here. And it's in a group by itself because it has special properties. Hydrogen doesn't act like the other alkali metals. That's why it's by itself. And hydrogen also will have 1 outer electron there. Now the chalcogens over here, some people want to call it chalcogens, but you know it's not chemistry, it's chemistry. So you say it with a hard C here. So the chalcogens include the oxygen family here. So we've got oxygen, sulfur, selenium, tellurium, and polarium. So these ones are the chalcogens here. Sorry, 1 second here. Okay, so they're group 16. They're common as minerals, so you find them in the earth, and they will all have 6 outer electrons or 6 valence electrons. Okay, next is our halogens. So the halogen family, fluorine, chlorine, bromine, iodine, and astatine. Group 17, they're very reactive. Now they are gases at room temperature, all of them, and they have 7 outer electrons. And lastly, we're going to look at the noble gases here. The noble gases is that last column, so group 18. Now, they have full outer shells, so which means from neon all the way down to radon will have 8 valence electrons, but for helium, because it's only got 1 shell, will have 2 outer electrons, okay? So helium, all of the noble gases, non-reactive. They do not react because they've already got full shells and they don't really need any more, so they're happy how they are. Now, your assignment today is to finish the outer electrons sheet and crossword puzzle. Okay, so you can give that a try. Thanks, everyone.